Hi you guys, welcome to the Where Did My Aluminum Go lab, and we are going to mix aluminum with copper 2 chloride today and measure a temperature change as the copper ions, which are positively charged cations, they're missing their valence electrons, steal valence electrons from neutrally charged aluminum atoms. Neutral charge just means they have equal numbers of electrons and protons, and that makes aluminum the state of matter that you'd see on the periodic table, which is black lettering, which is solid, which is that shiny silver material we all recognize as aluminum foil. Your first challenge is to set up your spreadsheet. Just follow the directions in the lab and you'll end up with columns that are too narrow. If you put your cursor in between the columns and drag, you can make them the width that you want them to be. Some of you might also wonder, well, where do you find that degree symbol for Celsius? And so go to the Insert tab, click on the omega symbol, and scroll this all the way to the top, and then on your way down, you'll see the degree symbol, and just insert wherever your cursor is located. You'll have to locate your cursor right there in front of the C first. In this lab, we want you to record temperature every 15 seconds, which is 0.25 minutes, up to 5 minutes. And we don't want you to have to type in all of those times. So I'd like you to use a shortcut. If you type in 0 and then 0.25, you can teach Excel to recognize a trend. So if you put your cursor right in the lower right-hand corner, do you see where there is a little green square right there? And you put your cursor right over that green square and it turns into a plus sign. Hold down your left mouse button and drag that. It will recognize the trend and continue that trend, placing a number value every 0.25 or a quarter of a minute as far as you want to go down. We only need to go to 5 minutes, so I can highlight these and delete those cells. Cool. Your lab instructs you to measure out 1.600 or 1.800 of this copper 2 chloride dihydrate. The dihydrate part of the formula is just meant to represent the fact that this stuff absorbs water from the air, and because of that it gets a little soggy or fluffy even. Throw your weigh boat on the scale, hit the tare button or the 0 button, and keep adding the copper 2 chloride until you get to that range between 1.600 and 1.800 grams. The next thing is to measure out 29.5 to 30.5 milliliters of water. And that's why we've given you guys a pipette, and that's why we've given you a beaker for your reservoir. There is a dish of water, water tension, right at the top of this column of water inside your graduated cylinder. And that's called a meniscus. You want the bottom of that meniscus resting somewhere in between 29.5 and 30.5. So use your pipette and your reservoir of water in the larger beaker. And just add water until you're comfortable that your volume is in between that range. Since there's a line for 30, I'm going to keep adding water until I see my meniscus right at the 30 line. And then I can say comfortably that that is 30.0 milliliters. Now you've got an opportunity to write down your volume, which equals your mass for the water. And that's convenient because water has a density of 1.00 grams per milliliter. So whatever you have for your volume of water equals your mass of water. And you'll have your copper 2 chloride mass here as well. Then measure the temperature of your water in your graduated cylinder. The temperature of my water this morning looks really close to 22.0 Celsius. And here's where you'll write your temperature of the pure water as it was in your graduated cylinder. Now things get a little more interesting. You get to take your salt and put it into your, I know I said salt, this is copper 2 chloride, and any ionic compound with a metal and a nonmetal is also called a salt. So we've got our salt in there, and the lab directions say just dribble a tiny little bit of water in there so you can observe how easily this stuff dissolves. And that water I took from my graduated cylinder, the 30.0 milliliters that I measured before. And once you've done that, pour the rest of the water in. You can swirl a little bit, get it to all dissolve. Also, please feel free to use your thermometer to stir it. Your thermometer is not technically a stirring rod, but once it's all dissolved, that green color should be Caribbean blue. Make sure once all your salt's dissolved that you've measured the temperature change. There's a temperature change for dissolving salts, and it has to do with bonds broken and bonds made during the dissolving. We'll learn a lot more about that this year. But what I'm seeing right now, and maybe you can see that too, right above the line, I'm seeing 23.1 degrees Celsius for the rise in temperature. And you'll write that change here. So 23.1 degrees, and we have a 1.1 degree rise in temperature just from the dissolving. That's what this delta means. Delta equals final minus initial. In other words, difference. This is the fun part. You've got your timer, you've got your thermometer ready, and you just roughly cut a piece of aluminum about 6 centimeters by 6 centimeters. And so one of your lab members is going to keep the thermometer in the solution of copper 2 chloride in water, while the other lab member starts out by just taking a small piece of aluminum and dropping it in and observing what happens. And at this point, you start measuring temperature change and keeping time. And I want you to measure the temperature and write it down on that data table every 0.25 minutes, which equals 15 seconds. Once you've made your initial observations of the aluminum, keep adding the aluminum in strips and keep measuring temperature and stirring with your thermometer. And at this point, it's starting to get effervescent, so make sure that you keep your goggles on and your hair is back. And it'd probably be wise to have the reaction mixture off of your lab sheet. You're stirring, you're observing, and you're measuring temperature every 15 seconds and writing that down or typing it into the data table in Excel. Once all your data is entered, it should look something like this. Then you can highlight your data table, go to the Insert tab, Recommended Charts, click OK. There's that trusty old medical marijuana symbol, and make sure you have axes titles clicked, and give me a really good title, like the effect on temperature of the reaction between aluminum and copper 2 chloride. Something that tells a story of what happened and what the graph is all about. You want somebody who's not in the lab to read the title and know what the lab is about. Here we've got temperature in degrees Celsius. Now you know where to find that degree symbol. And we have time in minutes. When you're ready to graph, click on your graph. Make sure that those little circles are bordering your graph. That's telling Excel just to print the graph, not the data table. All I want today is a graph printed and not a data table. And so it should be WYSIWYG, or what you see is what you get for printing. And this is my personal account, so the printer in the lab doesn't actually show up. But the default printer for you is going to be the one by Dr. Moody's door. Go ahead and print one copy for you and your partner. Finally, what do you do with the waste? Well, you've got this beaker now with some stuff that can't go down the drain. And so we'll have to treat it and make sure that it doesn't affect our fisheries. And so here in the middle of the lab, we've got a waste bucket or a waste jar. And just pour it in there. Then I want you to return to your table, rinse this in the sink. It's okay once it's dumped out. And rinse your thermometer and call it a day. Thanks very much, you guys. Good luck.